And now, ladies and gentlemen, we're pleased to present the grand prize winners in this year's competition. Those components that, in the eyes of this year's judges, exemplify the highest levels of PM's potential. GKN Sinter Metals LLC has earned the grand prize in the automotive transmission category for a carrier and one-way rocker clutch assembly made for Ford Motor Company. Used in the new Ford Super Duty Torque Shift 6-speed automatic transmission, the hybrid assembly contains 5 PM steel parts weighing a total of 17 pounds. The Sinter brazed subassembly consists of 4 multi-level PM parts, of which 3 parts, cage, spider, and carrier plate, are made to a density of 6.8 grams per cubic centimeter. In addition, there are 17 compacted brazing pellets. The rocker plate is sinter hardened during the sinter brazing phase and has a density of 7.0 grams per cubic centimeter. The assembly also has a double pressed and double sintered cam plate made to 7.3 grams per cubic centimeter density, with an ultimate tensile strength of 170,000 psi and a mean tempered hardness exceeding 40 HRC. To form the parts and maintain precision tolerances, innovative tooling was developed and used in conjunction with unconventional press motions. Ford subjected the assembly to stringent durability testing, ultimate torsional torque loading at a minimum of 8,000 foot-pounds, and fatigue testing at a minimum of 299,000 cycles at 1,730 foot-pounds. The application provided an estimated 20% cost savings over competitive processes and represents a new era in the scope and size of PM parts. GKN Sinter Metals LLC has also been awarded a grand prize in the automotive chassis category for a differential bearing adjuster made for its customer, American Axle and Manufacturing, and used in the GMT 900 rear differential on GM Tahoe and Yukon models. The diffusion alloyed PM steel part preloads the bearing and is locked in place through the side holes. Formed to a density of 6.8 grams per cubic centimeter, it has a 155,000 psi transverse rupture strength, 79,000 psi tensile strength, yield strength of 63,000 psi, and 90 HRB apparent hardness. A special die and dual upper punch design form the cross holes during compaction. Selecting PM saved the customer $320,000 annually by replacing a casting that required extensive machining. A porous bronze filter made by Capstan, California for Chase Filters and Components has received the grand prize in the aerospace military category. The filter, fabricated through gravity sintering, is used in an ignition-resistant, fault-tolerant oxygen cryopack filter for medical and emergency breathing systems. The filter's fluted design increases surface area, which in turn increases flow and dirt-holding capacity. The innovative design of the sintering mold allows the retention groove to be formed in the part, eliminating secondary operations. The PM filter replaced a more costly and less reliable stainless steel filter. Parmatech Corporation has earned the grand prize in the Hand Tools Recreation category for a large game 420 stainless steel hunting arrow 300 Extreme Broadhead made for Optech Precision Tooling Limited. Fabricated by the MIM process, the thin blade features a critical straightness necessary for accuracy, and the external thread is molded in the design. The part is formed to a final density of 7.7 grams per cubic centimeter and has a 48 to 52 HRC hardness range. Going the metal injection molding route saved 50% of the cost of machining the broadhead from stainless steel bar. The customer sharpens the arrowhead edge, the only secondary operation performed. A PM copper steel outer hub exit spindle used in electronic door locks has won the grand prize in the hardware appliances category. Made by ASCO Sintering Company for the Schlage brand of Ingersoll Rand Security Technologies, the part connects a standard lock and an exit device. When activated through a code or electronic card reader, The spindle rotates to the standard lock assembly. The PM spindle is made to 7.7 grams per cubic centimeter density and has a 95,000 psi ultimate tensile strength, 8% elongation, and 90 HRB hardness. The PM process allowed 95% materials utilization as opposed to machining a wrought blank, which yields a materials utilization figure of only 45%. PM also provided a 90% energy savings. Flowmet LLC has earned the grand prize in the medical dental category for a housing cup and lid used in an audio device with magnetic shielding capabilities. This application is the first of its kind in the high-power audio device sector. The anti-magnetic MIM material with high nickel content provides an electromagnetic interference, or EMI, shield, preventing interference from other electronic equipment. While the cup has 4 thin walls for proper assembly, the new lid design must fit securely into the cup opening. This is to prevent moisture and/or foreign matter from entering the housing, as well as to maintain the EMI shielding capability. Manufactured to 8.30 grams per cubic centimeter density, the parts have an ultimate tensile strength of 84,000 psi, yield strength of 32,000 psi, and a 40% elongation. Alternative manufacturing processes such as deep drawing, casting, and machining would have required multiple components. Combining these multiple components through the MIM process provided significant cost savings, in addition to eliminating up to 40% scrap loss. Ladies and gentlemen, those are the grand prize winners in the 2011 PM Design Excellence Awards competition. Please join us in warmly recognizing company representatives as they come to the stage to receive their awards.